Good afternoon. Good afternoon. Hope all is well. Hope everyone's doing all right. So we're going to give everybody a second to get in and then we'll get rolling. All right. So I think everybody's in here. So we are looking to go ahead and get rolling today. If you missed the first day of class, we just did an introduction, didn't do any lecture or anything like that. We're going to do that today, get started today. I do record every lecture and I will be sending it out to you guys before the end of the week. Most of the time I get those out on a Friday, maybe a Thursday night. So just an introduction, introducing you to math lab and all the good stuff like that, how we're going to handle class, due dates and all the stuff like that. So, if you missed first day of class, get a chance to take a look at that first video, or if you have any questions, feel free to email me. Email is always open for you guys. Other than that, let's look at before I do any quick questions before we get rolling.
Yes, I have one. So I know last class you mentioned something about us being able to do some of our work ahead of time. What is your the actual policy on that? Because I was going to go and do some of my assignments ahead of time, but I just don't know your thoughts and opinions on that.
Oh, do your thing, man. No limits. Just knock it out. If you're at a point where you can just freely knock out everything, everything's open. So I have no problems with you. Sorry, I had an alarm set. I have no problems with you guys working ahead at all. There's no penalty, I feel no ways about it. I think the more you can get done while it's easy to you, the better. So yeah.
So there's no limit on how far ahead we can go. It's just however far we can go to our knowledge if we do choose to do that, correct?
Right. The only thing only thing that would be a problem as far as the class is concerned if you get too far behind, but there's no such thing as moving too far ahead. Not at all.
Okay, got it. Thank you so much.
Yep, not a problem. Let's see, I was looking at this. Okay. All right, so let's go ahead and get rolling. Let me check one thing in this shell real quick. Make sure your assignments have been put in properly. Yep. Okay, so we are good to go. So also, I know your section, not your section, but your homework start off in 2-2. I haven't gone through it. They changed the book on me, and I haven't gone through and relabeling all of my sets. So we're starting actually 2-2, not 1-2. So same symbol, same content, same material. Everything is just that you guys starting at 2-2, not 1-2. So we're starting in chapter 2, then goes chapter 3, and so on. All right. So symbols and sets of numbers. Your natural numbers start off with the number 1 and goes on to positive infinity. So no decimals, no fractions, and you start with 1. Whole numbers start with 0 and then go to positive infinity, no fractions or decimals. So all of your natural numbers are whole numbers. The only difference between whole numbers and natural numbers is that whole numbers start with 0. So you can think about whole and zeros like a whole, something like that. But that's the only difference between the two sets. Whole numbers include 0. Integers, no decimals, no fractions, but now you're including negative numbers and negative infinity.
So all natural numbers would be 1 and 1, 2, 3, and all the ones above that, but not including any of the negative numbers, nor 0, correct?
Right.
Okay.
So all natural numbers are whole numbers, all whole numbers are integers. And then when we get to this next one, all of these numbers are rational numbers. And this is first day taking notes. So if anybody is copying something and I scroll up too fast or I don't move too fast. Anyway, you need me to see something else, feel free to type in the chat or unmute. Either way is fine. Of course, most of you do not have your cameras on, so I wouldn't know if you're still writing or not. So it's all about just letting me know. It's not a big deal. All right, so rational numbers. Oh, somebody saying something?
Yes, Professor. Are we in the book now?
Yes, this is coming out of the book.
What page are we starting on here?
Now that I don't know, but whatever page is 2.2 starts off with 2.2.
Okay, so we're starting off at 2.2. Now I have an e-text. How do I go straight to 2.2?
You would go to chapter content. Let me see your book.
Table of contents.
No, okay, so like on the left screen. So guys, let me show you this real quick. This will benefit you guys as well. So you see how you have e-text right here, but you also have chapter contents. You can do either one.
Oh,
chapter contents will take you right there, and then you can click on chapter 2, and then we said 2.2. And then if you just click on e-text, it'll put you right there at 2.2.
Okay, wait a minute, let me get through that. Give me just a second. Okay, wait a minute. Okay, well, shoot, I know how to do it now. Let me just skip the page. We're going to 2.2. No, I'm at 2.2. It'll say it at the top.
It should look like this.
Okay. 1 second.
So,
okay. Yes. So we're on 2.2. Decimals. Okay, wait a minute. Symbols. Okay, wait a minute.
All right.
I think I'm gonna skip past. I got all the way 3. You say you have no page numbers.
Say again.
So you say you don't have no page numbers.
Let me see. From what I see, does that say a page? Page 64.
Oh, I didn't know. Okay. All right. Let's see. Can I get it there? So I will still. You say. You don't top thing.
Wow, she 500 pages.
Next class, I'll know how to go straight to it. It's a 62.
64.
It's okay, I'm good.
All right, sounds good. So our next category of numbers are your rational numbers.
No. My 64.
Okay.
My 64 ain't showing review of real numbers.
So let's look at this. Stay back after class so we can possibly share your screen and I can see what you're looking at.
Okay.
Yeah, we'll do it like that. Yeah. All right, so next category of numbers, your rational numbers. It's any number that can be written as A over B, where A and B are integers. So 3 over 5, negative 7 over 9, and even 8 over 1, which is just 8, is considered a rational number. So all of your integers are rational numbers. All of your whole numbers, all your natural numbers are also rational numbers as well. And then in the green, I gave you another note towards your rational numbers, deciphering between what is a rational number, what's not. Any decimal that's terminal or repeating is considered rational. So an example there, 0.75 is the same thing as 3.4. So that's considered a rational number. then 0.33, that's a repeating decimal, then that can be rewritten as 1/3. All right, scrolling up a little. So irrational numbers, any numbers that cannot be written as A over B, where A, B over integers. I'll scroll up, show you examples of that in a second. Just giving everybody a chance to write. All right. So those are examples of irrational numbers. So those numbers will not, when you convert them to decimals, they won't repeat and they won't end either. So those are considered irrational. All right. In our last category of numbers are real numbers. Those are all rational and irrational numbers. So all the numbers we talked about up to this point are real numbers. You guys will not deal with imaginary numbers. That's another math class altogether, but there's such things as imaginary numbers if you haven't dealt with them before. So that's referencing, when you say real numbers, that means we have some numbers that are not considered real. But every number you guys will deal with will be real numbers. Any questions with our number categories? Make sure we're okay.
Can you go up just a little teeny bit for me? Example 0.37.
Right there, you need more than that?
That's good, that's good.
Mm-hmm.
I'm good if you're waiting on me.
All right. Well, look, I don't know who I'm waiting on right now. I'll just be just giving it a chance to marinate. All right, so let me do this with my number line.
Thank you.
Yeah, not a problem. All right, so with your number line, generic number line, zeros in the middle, then to the right of zero, all your positive numbers, to the left of zero, all of your negative numbers. With your number line, always keep in mind that the number that's farthest to the right will always be the greatest number. If you look at the number 1, anything greater than 1 will be to the right of it. Everything less than 1 will be to the left of it. If you were to look at -2, everything greater than -2 will be to the right of it. Everything less than -2 will be to the left of it. That will always be the practice. The greater number will always be to the right. The lesser number will always be to your left. All right, and that feeds into our inequality symbols. All right, is everybody good with the red? Can I keep on? All right. So here are 4 main inequality symbols that we will be using. We have your less than and greater than. Then the less than with the bar under it will be a less than or equal to. Greater than with the bar under it will be greater than or equal to. All right. So first exercise that they give us is to use the greater than, or less than, greater than, or equal to make a true statement. All right, so we have 2 and 7. First thing you want to do is establish which number is the greater one. From there, I remember my elementary teacher always said that, you know, the mouth is always open to the greater one because the shark is trying to eat the bigger piece. So you put a little teeth on either shark or alligator. I remember one teacher used alligator. So if you can't remember which words go to which, because all you're trying to do is create a sentence with these symbols that they're giving you mathematically. Just remember whichever ones are greater, and then the mouth is always open to the greater number. And so, you know, like I said, your teeth is right there. You know, the mouth is going to eat the 7 because it wants the bigger piece. Same thing with comparing the 100 and the 30. You know, 100 is greater than 30. So you will write your symbol with the mouth open to the 100. So this statement reads 2 is less than 7. And this is 100 is greater than 30. All right. Problems, any problems? And then the same thing with the -35 and the -4. And whenever dealing with negative numbers, remember I told you the number that's farthest to the right will always be the greater one. So there's a couple different ways you can look at how you would interpret what is greater when it comes to your negative numbers. -4 is closer to 0. -4 is further to the right. Then -35 is, or you can think about your money. Would you rather owe $4 or owe $35? Right. And so of course you would rather owe $4. And so 4 is going to be the greater of the two. All right. Questions on those before we go to the next one? Okay, so the next one, they give us a set of numbers and they want us to put it in the category of the numbers that we had previously. You know, we had whole numbers, natural numbers, integers, rational, irrational, real. So we want to take all of the numbers that fit into each one of those categories. So we have -2, and there are going to be some repeating because remember, some whole numbers are natural numbers and stuff like that. So there'll be some repeating. So here we have -2, 0, 1/4, -1.5, -3, 11, square root of 2, and square root of 81. All right. So I notated right here that the square root of 81 is 9. So don't forget that. Square root of 2, if you were to put that in the calculator, it would not, come out to an even, solid type number. It will be a run on decimals. So. All right. So instead of erasing these answers and putting them back in, I'm going to just leave them there and discuss them. So your natural numbers, if you look at A, you say, out of all of these, which one of these are natural numbers? So remember, natural numbers start off with 1 positive, and goes to positive infinity, no decimals, no fractions. So 11 fits into that category. And then if you take the square root of 81, that's 9. So that fits into that category as well. So be careful with Math Lab. You don't put 9 in there because they didn't give you the problem with 9. They give you the problem with the square root of 81. So you continue to use the square root of 81 throughout your answers. So are we okay with A before we go to the next one? We want to know what numbers in this set are natural numbers. And so the only two are 11 and 81. All right. So for the next one, whole numbers. Oh, didn't turn my commas. So you're talking about including 0. Okay, there we go. Including 0, but all of the values that were natural numbers are also whole numbers. So we use 11 and the square root of 81 as well. All right. Any problems with that? All right. So with integers, yep, let me do that. You will use all the values that are natural numbers and whole numbers, but also any negative values that are not decimals. So we will use -2 and -3 as well. So now rational, that will still use all of my natural, all of my whole, all of my integers. So all of these 3 categories should be here as well. So you see we have -2, -3, 0, 11, and square root of 81. But then we're looking at decimals. So you're talking about fractions, they can be written as an integer over integer. So that's 1/4. And then any terminal decimals or repeated decimals. So that would be -1.5. For irrational, it'll be the only other one that's in there, the square root of 2. So the square root of 2 is the only irrational. And then for your real numbers, that's all of them. So the whole set are real numbers. All right, questions, any questions? All right, is everybody good with the sets? All right.
Still learning.
Well, I understand some questions may not come up until later on, so it's all good. It's all good. All right, so the next thing, absolute value. So 3 things about the absolute value, but one main thing that you have to hold on to. First thing is that it's a counting tool. Second, it represents how many units a number is from 0. And the last thing, the third thing that you really want to hold on to, that's why I put the double asterisk beside it, is that the result is always positive. So in other words, if I have the square root, and I said square root, absolute value of 3, your answer is going to be positive 3. If you have the absolute value of negative 3, your answer is still going to be positive 3. It always produces the positive result. It's always positive. Because basically what you're asking yourself, how far is 3 away from 0? It's 3 units. Well, how far is negative 3 away from 0? It's still 3 units. So the result is always positive. And these bars, that's your absolute value sign. Bars, or the longer bars that have your number in between, that's your absolute value sign. All right. So just a few more examples down here. Absolute value of 0.25 is 0.25. Absolute value of negative 7/8 is positive 7/8. Absolute value of negative 100 is positive 100. So your absolute value symbol will always produce a positive result. All right. I think this is the last thing out of this section.
I have a question.
Yes, ma'am.
So how does -7, how does the absolute value of -7/8 equal 7/8?
Well, that's the effects of the absolute value symbol. It's just that's the application.
Oh, that's
So-
just how it works.
Exactly. That's just how
Okay.
it works. Yeah, there's nothing really for you to do, but just know that that's the application of absolute value.
Okay.
Yep. Good question. Good question. All right. Anything else with absolute value before we look at opposites?
I have a question. So for the it says that for the 0.25, so even if it's positive, it'll still end up being positive as well.
Yep.
I just wanted to make sure on that one.
Oh no, you're fine. You're fine. Yep. So that's how it always works, whether it's positive or negative. If you apply the absolute value, the result will always be positive. Yep. Good question, because a lot of times people will do the opposite. But yeah, absolute value means positive. Positive. All right, can we scroll up? Everybody good? All right, so in mathematics, when you talk about opposites, it's either positive or negative. So those are the only 2 types of numbers you'll have when it comes to your signs. So if you have a +5 and they want you to write the opposite, then that means you write -5. If you have a -10, they want you to write the opposite, then they want you to write +10. Applying the negative symbol to a number will produce the opposite. So that's what I was emphasizing right here. Negative to a negative turns a number positive. And then of course, negative to a +18 will be a -18. So that negative symbol will convert your answer to the opposite, as long as you hold true to, what the negative symbol does. All right. Now here in this example, we have to be careful. Now, we just finished talking about the absolute value. So now, absolute, y'all, and let me say it like this. Mathematics says a lot with a little. In other words, they do their best to not have to write sentences or words, and they use these symbols to make statements, just like we were talking about the greater than symbol, less than symbol. 5 is greater than 2. That's a whole sentence that will be written just using these three symbols, two numbers and one symbol. So that's a sentence though. So we have to be careful with our symbols and make sure we apply the proper symbols to what's going on. Here we have the absolute value symbols. Absolute value of negative 21. We just finished talking about how that result will be positive 21. Now, after you apply the absolute value symbols, you can use a parentheses in order to emphasize that this negative right here is still sitting on the outside. So you have to be careful because the book we're using this way and expect you to know that these symbols, the symbols have shifted and changed. Parentheses don't have any value. They don't do anything to you. All they do is group. They're called grouping symbols. But absolute values, you know, they change your symbols according to what's going on. Change your signs according to what's going on. Remember, the result will always be positive. So when I look at negative 21, the absolute value of negative 21 is positive 21. So that's what happens here. But this negative is not affected by these absolute values because it's sitting on the outside. And so that's why I have this negative still sitting on the outside. And so your ultimate result will be that negative 21. So you have to be careful with the positioning of your negative signs, absolute values, and so on. So, you know, the more you use them, the more you get used to them and stuff like that. And so here I want to show the difference. Now, if I just had a grouping symbol and not the absolute value, what this does is I'll allow a negative to a negative to be applied to each other. And my result would be positive 21. We see how the other one yielded a negative 21, but that was because we had absolute values here. So it's going to be important that as you get immersed into this section and moving forward, that you pay attention to your symbols, because most definitely they will dictate whether you get the right answer or the wrong answer. All right. So questions on those two before we add a little more to it. Make sure we're okay.
That's what I was gonna ask.
Okay, okay, cool.
That we have to make sure that that negative is pointing there. I'm sorry, I have pneumonia. That's why you can't hear me that good.
Oh, that's fine. You're fine.
Okay. To make sure that that number has that symbol there. Because if we don't put the symbol, it could be wrong.
Mm-hmm.
Okay.
Mm-hmm. Yep. Oh man, I hope you feel better. I hope you feel better. I most definitely commend you for trying to sit in the lecture, because I would have just had to catch the video if I was you. Yeah. So any questions? Yeah, we just only got a couple. Yeah, so we got plenty of time. So we'll look at 1, 3, and then call it a day. Well, 2, 3. Sorry, 2, 3, and call it a day. Any questions on 2.2 before we look at 2, 3? All right. So as always, it will be important that you get in the math lab in a timely fashion so you can start implementing the things that we talked about today. And you don't want to, especially if you haven't seen this stuff, if you haven't seen it before, haven't seen it in a while, you don't want to let it sit out there too long without trying to apply it, because then it may be like you never sat in class. So you do want to go and start attacking math lab as soon as possible so that you can apply the things we talked about today. So 2.3 is your exponents, order of operations, variables, and equations. So the first thing, exponents. So here we have 2 to the 3rd power, or 2 cubed. So the regular size number is your base, and the superscript number up to your right, the smaller number, is your exponent. So what that means is that I'm going to multiply 2 times itself 3 times, and that'll give me 8. Now, if you were to flip the positioning of the 2 and have 3 as the base, and then 2 is your exponent, notice you get a different number. So do make sure that you're applying these properly as well, and make sure you're not multiplying. So an easy number for us to, for a familiar tandem is 2 times 3, and it gives us 6. I've seen plenty of people to write 2 cubed and write 6, and so be careful with this. Here we have our exponents here, and so that means you will multiply that number times itself that many times. So be careful with that. All right. Any number to the first power is going to be itself. Let me see if I got general. Okay, no. So any number to the first power is going to be itself. So that's why you have 7 to the first power is just 7. And then if you're going to apply the exponent to a fraction, you can actually apply the exponent to each, the numerator and denominator separately if you like. But if not, you can write it. In this case, we have 3/5 squares. It's 3/5 times 3/5. So 3 times 3 give you 9. 5 times 5 give you 25. All right. Any problems before I scroll up? Make sure we're okay.
Yeah.
Mm-hmm.
Okay, you said, okay, 3 times 3 is 9. Then, okay, the 5 times, okay, I get it. I get it now.
Okay. Cool.
I get it. Sorry.
That's all right. It's all right. Anybody else before we scroll up? All right. So let's look at order of operations. Pemdas. Please excuse my dear Aunt Sally or Shantae, depending on, I guess, your auntie's name. So this is one of those things that everybody gets wrong. I won't say everybody. A lot of people get wrong, whether it be on Facebook, Instagram. They put a little order of operations up, and yeah, they mishandle the order of operations. So hopefully we can bring some clarity, and then you can be the smart one in the chat, and make sure you get that right so that everybody else can look at you and marvel, I guess. So PEMDAS, the first one is P, and that's going to represent our grouping symbols, parentheses, but any brackets or braces represents our grouping symbols. So you will see either one of these 3 sets, not just parentheses, but brackets and braces. Now, remember, they don't carry any value like that, absolute value. Remember, absolute value makes you result in a positive number. They just group your stuff together. That's all they do. Exponents, just finished talking about that. Multiplication, division, addition, and subtraction. So notice on the left, I got the numbers 1, 2, 3, 4. And this is where we start getting into why people get this stuff wrong. There are only 4 tiers of operations. The first thing that should get your attention are your grouping symbols. Second thing, exponents. The third thing is multiplication or division. Both of those are seen as being done. I'll put it like this, that both of them on the same level, and you will see them from left to right. So whichever one comes first is the one you would do when it comes to multiplication and division. And then the last thing you look for is addition and subtraction. And once again, you do those from left to right as well. They are on the same level. So multiplication does not take precedent over division. Neither one of them are more important than the other. You do them from left to right. And that's where a lot of people make the mistake. Same thing with addition and subtraction. Subtraction is not lesser than addition. You do them from left to right as you see them in that final tier, in that final step. All right. Question, well, not questions yet. Let me do this. So I have a simple example, just emphasizing that left to right process, making sure we're okay with it. 18 divided by 9 times 2. Now, if we strictly go by the positioning of those letters, that would suggest that multiplication be done first. So if you do 18 divided by 9 times 2, if you do 9 times 2, that'll be 18. 18 divided by 18 is 1. So I like to do a problem like this to emphasize that just because you get a solid number does not mean you are correct. All right. So what you're supposed to do is division first, because from left to right, division comes first. So 18 divided by 9 is 2, then 2 times 2 is 4. And that is your correct answer. All right. So once again, multiplication does not necessarily take precedent over division. It's not one that we get your attention first. Multiplication and division, you do them from left to right. So whichever one comes first in the process, that's the one you would do. And then addition and subtraction the same fashion. Once again, if they're in grouping symbols though, that take precedent. Your grouping symbol comes first. So if you have multiplication in a grouping symbol, yes, you're gonna do that first because it's in your grouping symbol. And so, but those are the things that should get your attention in the order.
So in this problem, you got 18 divided by 9 minus 2
Times 2.
times 2.
Yeah, that's a dot. Yep.
Okay, so 9 times 2 is 18. So how do we get the 18 right here?
Well, okay, let me do this. So this is the wrong way of doing it. Okay, so 9 times 2 is 18.
Right?
And so 18 divided by 18, this is still the same 18 right here. I don't know if that's what you're referring to. I said 9 times 2 gives you this 18, and this 18 comes right here.
Right. Okay.
And, all right. Yep. And so, but that's the wrong way of doing it. So the first thing we should have done was 18 divided by 9. And that'll give you 2. And then this 2 is still right here. And then 2 times 2 is 4. Anybody else before we look to do more order of operations? So now what we're going to do is just do more problems, emphasizing the order of operations. So these are 2 different problems. This is one problem over here, another problem over here. So we'll look at this first one over here first. We have 6 divided by 3 plus 5 squared. So instead of erasing the process, I'm just going to walk you guys through it. So the first thing we should do is the 6 divided by 3. I mean, shoot, I said 6 divided by 3. First thing we should do is the 5 squared, which is 5 times 5. And that gives us 25. All right. Next, we have 6 divided by 3 plus 25. We should do 6 divided by 3. And that gives us 2. And then 2 plus 25 will give you 27. All right, so once again, in the first problem, exponent gets our attention first. So 5 squared is 25. So then we have 6 divided by 3 plus 25. 6 divided by 3 is 2. And 2 plus 25 is 27. Next one over here, 20 divided by 5 times 4. First thing that gets our attention is division. So 20 divided by 5 is 4. 4 times 4 is 16. All right, let's look at some more. All right, so here we have 2 times the quantity of 12 plus 3 divided by the absolute value of negative 15. So this is our whole original problem right here. So first thing we want to do is what's in the parentheses. 12 plus 3, which is 15. Then if we want to go ahead and simplify what's in this numerator, 12, I said 12, 2 times 15 is 30. Now here we have absolute value. Absolute value of negative 15 is positive 15. And then 30 divided by 15 is 2. So always hold on to the idea that if I have a fraction, that's also the division process. So 30 divided by 15 give us 2. All right. So make sure you guys are holding true to, when you do your scratch work, that you walking through these processes. Remember your first test, I do expect to see scratch work. I know that you can put most of the stuff in the calculator. You can put this in the calculator and be done with it, right? But if that's all I'm holding you to, then really I'm just shooting the breeze right now. So really, we're trying to emphasize these steps, especially in this first chapter. Once we start moving past these steps and emphasizing that, then you can start taking shortcuts and using more calculator work. And there's nothing wrong with using your calculator to check your answer as well. But I do need to see stuff like this Remember on your test, you're supposed to be shooting me scratch work. So I do need to see stuff like this, especially for this first test, to make sure you guys are holding true to the processes.
The absolute number, whatever the negative 15, how do you get rid of that negative? I missed it out.
Oh, yep, absolute value. Whenever you have these long bars, engulfing your number, that just means the result will always be positive. So even if that was the absolute value of positive 15, your result would have still been positive. All right. So that's all that happened right here. It's just the application of the absolute value gave me a positive 15.
Would it ever stay negative? In what case would it stay negative?
Say that again now.
In what case would it stay negative or not?
Never.
Okay.
Yep. As long as the absolute value here. Now, if the negative is sitting on the outside of the absolute value, then the absolute value is not being applied to the negative. So that would be negative, but that's because the negative is on the outside. If anything is on the inside of this absolute value, it's always going to result as a positive.
Got it. Okay.
All right. Here, I think somebody asked a question about the absolute value. So this is the same problem, it's just that no absolute value symbol. So everything will still hold true. It's just that now you have negative 15 in the bottom, and that will give you a negative 2 when you do your division. 330 divided by negative 15.
So, Professor,
Mm-hmm.
I did want to ask,
All right, you're going in and out. I can't understand you.
if it is negative on
Uh-huh.
outside of the absolute value bars, then it will be a negative number. So it would have been negative 15 if they had been outside the bars.
Yes.
Okay.
Yep. You're all right.
So no, not with two negatives. It would just been one negative.
Well, either or. Yeah, either or.
Okay.
Because remember, whatever goes on in here is going to come out to be positive.
Right.
Yep,
Okay.
Yep, you got it. Also, what I'm going to do, I need to write a note to myself. Hold on one second. All right, so I have a short video of dealing with sign numbers, just in case anybody forgot, because this class and this section actually, talks about sign numbers as if and you've had the class with sign numbers and you remember all the sign rules. So I got a short video to discuss sign number, positive and a negative, negative, positive, negative to negative, just in case anybody, want to take a look at that addition, subtraction, multiplication, division, basically emphasizing stuff like this. So I'll send it out to you guys. There's nothing that you have to look at, but just in case somebody wanted to. All right. So now here, this is the original problem. And so now we're looking at fractions. And if anybody wants a video to reinforce the fractional process, let me know as well. But multiplication and dividing fractions versus adding and subtracting fractions. So that's what I was notating right here in the purple. We have 3/2 times 1/2 minus 1/2. The first thing that we have to do is to multiply. We have to multiply and subtraction. So you do not need common denominators when you're multiplying or dividing fractions. So all we're going to do is multiply 3/2 times 1/2. And that's what we're talking about right here. And you just multiply across, that'll give you 3/4. All right, so that's what we have right here, 3/4 minus 1/2. And then the green statement, you must have common denominators to add and subtract fractions.
You said, what did you just say then? Oh, you must have common denominators to add and subtract. Okay.
Mm-hmm. Mm-hmm. All right. Let's scroll up. All right. So first thing we want to do is look at these denominators. We want to ask ourselves, what's the LCD? The least common denominator. Least common denominator is the smallest number that each denominator can divide into evenly. So not what can divide into them, but what numbers can they divide into? So, 4 can divide into itself and 2 can divide into 4 as well. Now, let's say if you saw 8, let's say you just multiply 4 and 2 together and say, I'm going to use 8 as my common denominator. That's fine. Eventually, you'll get to the same number. You just be dealing with a little bit larger numbers than what somebody would use if you had the LCD. And that's not that big of a deal. But, as long as you have common denominators, that's all that matters. And then from there, you can reduce at the end. All right, gonna scroll up. All right, so 3/4 minus 1/2 or 1/2. This denominator, this fraction does not change because I already have 4 as the denominator. And then when I look at 1/2, you ask yourself what times 2 would give me 4, and that is 2. And whatever you do to the bottom, you have to do to the top in order to keep your equivalency. So 1/2 will turn into 2/4. And now that I have 2 fractions that have the same denominator, I can go ahead and subtract them from each other. 3/4 minus 2/4 will be 1/4. Denominators stay the same, and I just subtract my numerators.
And that is because of addition, you have to have the same denominator. Okay.
Yep, addition and subtraction. Yep.
So you don't have to subtract the 4 minus 4, right?
Right. No, you would leave those the same.
Okay.
Mm-hmm.
Why did we leave it the same again?
That's the fractional process.
Okay.
Yep. When it comes to addition and subtraction, that denominator stays the same. Notice when we did multiplication and division, it didn't. You do multiply across. But that's the difference between multiplication, division versus addition and subtraction.
And if they're not the same, you have to make them the same.
Yep. Mm-hmm. Yep. There's no way to add and subtract fractions unless you have those common denominators. All right. Scroll up. We okay? Can I go to the next one? Okay. And I'll get send one on fractions too, just in case anybody want to look at it. And then from there, if you have any more questions, always feel free to ask. Like I said, once I set up my office hours, you'll be able to come to office hours, or if you want to set up a separate Zoom session, we can do that as well. So, all right. So the next one, we have 3 times the quantity of 4 plus 2 times 10 minus 1. So notice we have 2 sets of grouping symbols. Whenever you have that, you want to do your innermost grouping symbol first. So the first thing that will get our attention, that should get our attention, is the 10 minus 1.
Subtraction.
Mm-hmm.
So we subtract the 1 from 10, that's 9, then to the 2.
Mm-hmm. You got it. And so, like she mentioned, we're still inside of our grouping symbols because we haven't simplified everything as much as possible inside. So that'll be 2 times 9, which would be 18. Still inside of our grouping symbol. 4 plus 18, which is 22. And then 3 times 22 is 66.
a minute. And it'll be two, and then it'll be 3 times 22. Okay. 66. Got that. Hey.
So we just gotta remember everything starts from the left to the right.
Yep, you read it from left to right, just like you would like read a book. You know, it's that same thought process going from left to right. Yep. And now the only reason you would deviate from that left to right process is if something gets your attention according to your order of operations. So you know, we didn't go here because we had these grouping symbols that made us go right. You know what I mean? So your grouping symbols and stuff like that can pull your attention there. But if that's not the case, then you go from left to right. All right, hold on. So let's see how much more we got. The variable. Okay, we don't have much left. All right, is everybody done with that last one? So try these order of operations out. And if you can't, figure out one or two or something like that, feel free to bring them to class and we can make sure everybody had clarity on what you see. Okay. Once again, if you're pulling from Math Lab, that would be the best practice versus pulling something from left field that you saw on the internet because you were Googling something. But I'll do that too if you want to see it. But make sure if most definitely you pull it from Math Lab, that will that will be a more focused problem that would be, geared towards what you guys will be dealing with. All right, so variables are just letters that represent unknowns. In this case, we're starting off with evaluating with these variables, and it says evaluate if x is equal to 3 and y is equal to 2. So they give you these algebraic expressions, and basically all you're going to do is plug in 3 for x, 2 for y, and then perform your order of operations. So the first one over here to the left, we have a. They give you 2x minus y. So once again, x is 3, y is 2. So that's 2 times x minus y, 2 times 3 minus 2. So the first thing we would do is 2 times 3, which is 6. And then 6 minus 2 is 4. All right. Next one, x squared minus y squared. Once again, directions haven't changed, so you hold true to it. At least, okay. And then that'll be 3 squared minus 2 squared. 3 squared is 3 times 3, which is 9. 2 squared, 2 times 2, which is 4. 9 minus 4 is 5.
Professor, what you said that definition of a variable was? It represents
Just represents an unknown number. So what's going to happen is as we progress forward, you may get something like 2x plus 5 equal to 7. And you want to know what value for x will make this a true statement. Then that gets us into solving for x. But right now it's unknown. And so if we didn't have these statements or this statement, we wouldn't know what x and y would be, but they would represent an unknown number. All right, everybody good on that? And that takes us to the next thing. Now, we're not going to solve yet. We're not going to get into solving, but we're going to talk about solutions, setting the foundation for solving when we get there. So an equation is a statement that 2 algebraic expressions are equal. So a simple example of that is x plus 5 equal to 8. Once again, remember, we're talking about mathematics. They give you these symbols that represent a statement or a sentence. So this says that x plus 5 is equal to 8. And so solutions will be value or values that will make an equation true. So in this case, what value will make that statement true is when x is equal to 3. So 3 plus 5 is equal to 8.
That's the equation, and then the solution.
Was that a question for me? Just talking to yourself?
So,
Okay, not a problem. Say it again. You broke up.
did you say we're not getting into solutions?
Oh, no, we will eventually. We're not going to do it right now, though.
Yeah, that's what I'm saying.
Mhm. All right. Well, I'll say it like this. We're not getting into solving for it. So the next exercise is that they want you to determine if it's a solution or not. So all we're going to do is plug it into the value for X and see if we get a true statement. So remember, that's the deciding factor on whether a value is a solution or not, is if it produces a true statement. All right. So here it says decide whether 2 is a solution of 3x plus 10 equal to 8x. And so that just means we're going to plug in 2 wherever we see x. All right. So that's 3 times 2 plus 10 equal to 8 times 2.
Mhm.
All right. So 3 times 2 is 6. Um, 8 times 2 is 16. 6 plus 10 is 16. 16 equal to 16 is true. So 2 is a solution of the equation.
Oh, I didn't see that on the side. I wonder where you was getting them numbers from. 2 is the solution. Okay. So let me write that 2. Okay. Ready. Oh, and the 8x, we got to add that too.
Mm-hmm.
Okay. And it says it's 8 times 2. Okay. So 2 times 2 is 16, yeah. 6 plus 10 is 16, yeah. So that is a true statement.
Mm-hmm.
Okay.
All right. Everybody good before we go to the next thing? Last thing. All right. So translating phrases to algebraic expressions. So keywords on page 23, that's probably not accurate for this new book. Let me see, this is section. See if I can find that page for you guys. All right, come on, come on. As a matter of fact, while I look for this page, I'm gonna scroll up and copy. Okay, almost there. Translation, what page is this? Page 79. Yep. Okay. All right, so that's actually page 79 for you guys. If you want to see, there's a box with just key phrases. As a matter of fact, do it like this. So page 79 is a new page for that. So they give you an expression and ask you to write it numerically or mathematically, or write it as an algebraic expression. So the sum of a number and 3. So sum means add. So if you're talking about a number, remember we talked about variables, how they represent an unknown number. They didn't give you the value. They just said the sum of a number and 3. So this is x plus 3 or 3 plus x. Both of those mean the same thing. You know, just like 4 plus 5 is 9. And 5 plus 4 is 9. So it doesn't matter the order when you're talking about addition. So both of these give you the same value. Twice a number is 2 times a number. So that's 2x. 5 times a number increased by 7. And so that's 5 times x plus 7. All right. So now this said write each as an algebraic expression. The next exercise, last exercise, says write each as an equation. So if it's an equation, that means there should be an equal sign involved somewhere. So just trying to give you an idea as to how your directions could give you a hint as to how you should be setting this stuff up. An expression does not have an equal sign. An equation has an equal sign. And the word is, most of the time, is your indication that that's where your equal sign will be. So if I look at this next one, it says the quotient of 15 and a number is 4. So quotient is division. So 15 and the number, the quotient of 15 and the number is 15 divided by x. You could have written 15 divided by x, you know, with that division symbol as well, could have used that. But I used a fractional bar. Both of those mean the same thing. Is 4. So the equal sign is your is. Next one, 4 times a number added to 17 is not equal to 21. So this time you will use the equal sign with a slash. So is not equal. Is there another one? Oh, that's it. All right. So questions on anything we've written, talked about. So when you try anything, if you have any problems, make sure you bring those problems to class. Or like I said, one of our sessions, opportunities, you can email me as well. But just don't sit on an island alone, because you don't have to. And most of the time we do have opportunities during class for questions. And for the most part, before any test or the close out of any section that we have, a chapter that we have, not close out a section, close out of a chapter, I'll set a day up that you can just bring whatever questions you have to the class, your review day. So we'll have plenty of opportunities for you guys to ask whatever questions you want to ask. All right.
I missed the first day of class, and I was wondering, so I got the ebook. Where do we do the modules or the work for this course at?
In Math Lab. So when you go to Math Lab, all of your assignments will be here. Click assignments, and there you go. And so notice how all the due dates right now, May 1st. I will change that when we get closer to closing out the first block of assignments. So when we get closer to closing out chapter 3, I will put a due date, which are normally on Sundays. to to encompass that group or that block of work. And so due dates will shift it will shift from 5-1, but for every block of work. So when we get to chapter 10, once we get ready to close out chapter 10, I'll set a due date for chapter 10's work. So our due dates are based upon the pace of our class.
So I can you went over the book with your own writing there, and so we just finished the quizzes in the book in the math lab, basically.
Yep. So we did 2-2 and 2-3. Let me see. I am sharing this. Yeah. So we did 2-2 and 2-3 today. Next class we'll get into 2-4 and then 2-5, and we'll just keep rolling according to what's in our math lab.
Okay.
All right. Anything else? Anybody else? Everybody good? All right. So I'll be making I made the recording. It's being recorded now, but I'll be converting everything to YouTube and shooting you guys that link, so you'll be able to review class 1 and today as well at your leisure. Those other videos, I'll send those to you as well. The one on sines and fractions for those who want to take a look at that. But other than that, anything else before we close? Don't forget, Monday you're off, so I won't see you again till Wednesday. Ms. Glover, I see. Did you unmute?
No, I'm good.
Okay.
Never did mute back up.
Okay, cool. All right, so if you guys are good, I'm good. Have a great weekend. Have a great holiday. Be safe. I won't see you till Wednesday, so try this chapter, section 2 and section 3 out. See if you can get through it and be done with it. So when you come in, you're done with those sections and be able, ready to roll into 2.4. All right. So, but remember, if not, no harm, no foul. You do want to get into it as soon as possible, but you don't have to have everything done by the next time I see you. But I just think that's a good goal to have if you can just be done with it and be ready to roll into 2.4. But other than that, you guys have a good one. Be safe, and I will see you on Wednesday.
Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you. Y'all have a good one. Take care.
You too.